Alright guys, you are watching the last video for questions 5 and 6 from the 2019 free response questions. We are going to start with number 5. It says, let each region R be the region enclosed by the graphs of g of x, which is -2 plus 3 cosine, and h of x, which is 6 minus 2 x minus 1 squared. So the first thing that I want to point out to you is that this bottom one down here, this is my cosine graph. This is g of x. You can tell by the shape here that it's kind of, you know, like cosine-y looking. Okay, then my other one is a parabola. It opens down. Okay, which we can see right there. That's my h of x. So for part A, it says find the area of region R. So area, remember, is the integral from 0 to 2. Those are my x values. And then I do top minus bottom, so it's h of x minus g of x dx. Now we are going to work that out down here. However, that part takes forever, so we're going to go ahead and do parts B and C, then we'll come back to finish part A. So part A, you have it set up. We're going to do it down here, but look at part B. Part B says region R is the base of a solid. For the solid, at each x, the cross-section perpendicular to the x-axis has an area, and then boom, find the volume. So remember that volume is always the integral of area. So if I automatically know the area formula, I just have to integrate that to get to volume. So for part B, I'm going to integrate 1 over x plus 3 dx. And then remember that if this is dx, then these have to be x values, which means I'm going from 0 to 2. Now this does involve u sub, so my u is going to be an x plus 3. That means that my du is a 1 dx, which means that dx is du over 1. So when I rewrite my integral here, it's going to be the integral of 1 over u du. Now you can put the over 1 on it if you want to, but you don't have to. Then remember that my endpoints are going to have to change, so if it's a 2 and a 0, I'm plugging those in here. 2 plus 3 is a 5, 0 plus 3 is a 3. Then from there, the integral of 1 over u is ln absolute value u, plugging in a 5 and a 3. On top, I'm going to get the ln of 5. On bottom, I'm going to get the ln of 3. And then remember that when you have ln 5 and ln 3, you subtract those as your final answer. So your answer would just be that subtraction. Now, you could have reduced that to be the ln of 5/3 if you wanted to get a little fancy, but up to you, totally was not necessary. Okay, look at part C. Part C says, write but do not evaluate an integral expression that gives the volume of this solid generated when R is rotated around y equals 6. So the first thing I want you to do is draw y equals 6. Okay, y equals 6 in your graph is going to be just slightly above. So I have 1, 2, 3, 4, 5, 6 is here. And then if I'm rotating around that line, you should notice that although I am touching that line at one point, for most of it, I'm separate. So my little r is going to be from here to here. And my big R is going to be from here to here. So I can see that I'm going to have two r's. Little r is going to go to the closer function. Big R is going to go to the farther away function. Then I also notice that my little r is 6 minus h. And then my big R is going to be 6 minus g of x. Okay? So I have 6 minus h of x for little r, 6 minus g of x for big R. Then from there, all I have to do is write my volume. So for part B, C, I would have volume equals pi integral 0 to 2 capital R squared, which is 6 minus g of x squared, minus 6 minus h of x squared dx. That is a squared right there. Hopefully you can see it. Okay? Alright, so let's work out part A. So this part took forever. I'm sure you'll get partial credit. But let's set up our integral the long way. So it's 0 to 2. H of x is the same as 6 minus 2, x minus 1 squared minus. And then it's h minus g, which is negative 2 plus 3 cosine pi over 2 x dx. Now, what makes this tricky is that you have several different parts and they all have to be evaluated differently. So the first thing that I'm going to do is distribute this negative sign here. So really, I have 6 minus 2x minus 1 squared. Then minus a negative is really a plus 2. And then my plus 3 is now a minus 3 cosine pi over 2x dx. Okay, then to make this a little bit easier, I'm going to combine like terms here. If I have a 6 plus 2, that's really just an 8. Okay, and then what makes this integration so annoying is that I basically have to split this up into 3 integrals. This one is regular. I don't need anything fancy to integrate 8, but this one is going to need u sub, and then this one is also going to need u sub. So you're essentially breaking this down into 3 separate integrals. Each integral will give you a different value. So let's do our first integral just on our 8. So if I integrate 8, I'm going to get 8x. Then I'm going to plug in my endpoints, which are 2 and 0. When I plug in 2, I'm going to get 16. When I plug in 0, I'm going to get 0. Then I'm going to do 16 minus 0. I'm going to get 16. That is part 1 of my integral. Okay, second part. I have the integral from 0 to 2 of negative 2x minus 1 squared. So my u is going to be x minus 1. That means my du is going to be 1 dx, which means that my dx is du over 1. So from here, I'm ready to rewrite my antiderivative. So it's going to be the integral of negative 2u squared, because remember, this is now my u. Then my du has an over 1. Nobody cares about that. And then I need to remember to change my endpoints. So if this is 2 and 0, plugging them into x minus 1, 2 minus 1 is 1, 0 minus 1 is negative 1. And remember, I still need to do the antiderivative though from there. So I'm going to add 1, my u is going to be cubed, then I'm going to divide on the negative 2, now it's a negative 2 over 3. From there, I'm going to be plugging in capital F of 1, capital F of negative 1. Okay? So think about when I plug in positive 1, I'm going to get negative 2/3 times 1 cubed. Well, that's going to stay the same. Then for my negative 1, when I cube that, I'm going to keep a negative, but then I have to multiply by this negative, so I end up getting positive 2/3. However, remember that when you do your second fundamental theorem, you're subtracting these two. So if I do negative 2/3 and then minus 2/3, I'm going to get negative 4/3. So that is the value of my second integral. Okay, last integral, we have our integral from 0 to 2 of negative 3 cosine pi over 2x dx. So my u is going to be pi over 2x. Then the derivative of pi over 2x is just pi over 2 dx, which means that dx is 2 over pi du. So I'm essentially taking my fraction there and I'm multiplying by its reciprocal on the other side. Now I'm ready to do my rewrite. So for my rewrite, I'm going to have the integral of negative 3 cosine u, and then my du has a pi over 2 in front of it. Now obviously I'm going to take that to the front, pull it to the outside just to kind of get it out of the way. So from there, I have a negative 3 pi over, and actually, do you notice I wrote this upside down? This should have been a 2 over pi. So please correct that. Remember, the 2 is on top, the pi was on bottom. So when I pull my 2 pi out to the front, it's actually going to be, if I do negative 3 times 2, that's a negative 6 over pi in the front. And then the integral of cosine u du. Sorry about that. Okay, then from there, I need to plug these endpoints in, 2 and 0. When I plug in 2 to pi halves, think about it, I'm going to have 2 times pi over 2. Those are going to cross out and just give me a pi on top. Plug in 0. Pi over 2 times 0 is still 0. Then I'm going to write my antiderivative. Antiderivative of cosine u. Okay, think about your snow cone, snow cone. Okay, if I'm on cosine, the antiderivative of cosine is sine. I'm going to keep my negative 6 over pi out there in the front. So I'm going to have a positive sine u out here. Then I'm going to plug in pi and 0. But the sine of pi is 0. Sine of 0 is 0. So when I subtract these two guys, I'm going to get 0 for that third integral. So you can put a plus 0 on your final value if you want to. Totally up to you though. But you did have to break that up into 3 separate integrals, which is what kind of made part A take forever. Okay? All right. Good job. Turn over to number 6, please. The last question. Okay, first thing you should notice on number 6, it says that f, g, and h are all twice differentiable. Then it says that g of 2 equals h of 2, which equals 4. Then it says that this line is tangent to both the graphs of g at 2 and of h at 2. So, kind of weird, but my line is tangent to both of my graphs at that value. Okay, part A says find h prime of 2. Okay, well I want you to think about that if my line is tangent to the graph of h, then what that means, h is tangent to the line at x equals 2 means they have the same slope, right? And if they have the same slope, then that means that they have the same derivative. Now, I don't have an equation for h, but I do have an equation for my tangent line. So for part A, the first thing that I'm going to do is I'm going to rewrite my equation of my tangent line. I'm going to have y equals 4 plus, and then I'm going to take my 2/3 and I'm going to multiply it into that x minus 2. So I'll have 2/3 x. 2/3 times minus 2 is minus 4/3, and then I'm going to take y prime. Now the derivative of 4 is a constant, the derivative of 4/3 is a constant, but the derivative of 2/3 x is 2/3. And remember that if 2/3 is the slope of the line, then it is also h prime at 2, because at that point my tangent line has the same slope as my graph. So I'm going to put h prime of 2 equals 2/3. Okay, that's my answer for part A. Part B. Part B says let a be the function a of x equals 3x squared, or cubed, sorry, times h of x. Then it says write an expression for a prime, then find a prime at 2. So if I want a prime of x, the first thing that you should notice is that I'm going to have to do product rule. Okay, I have 3x cubed multiplied by h of x, that is a product. So my u is going to be 3x cubed, my v is going to be h of x. Well then my u prime is going to be 3 times 3 is 9, then I'm going to have an x squared. My v prime is going to be h prime of x. And then from there I'm ready to set up my product rule. So it's going to be 9x squared times h of x plus then 3x cubed h prime of x. Now notice they asked me to find two things, a prime of x and then a prime of 2. So my a prime of x, I've already written. My a prime of 2 is going to be when I plug my value in. So it'll be 9 times 2 squared times h of 2 plus 3 times 2 cubed times h prime of 2. And what you're going to notice is that some of these values I already have, right? So the first thing that I notice is that my 9 times 2 squared, okay, well 2 squared is 4. 4 times 9 is 36. H of 2 was given to me in the problem. If you look up here, it says that h of 2 is 4 plus 2 cubed here is going to be 8, and then 8 times 3 is 24. Then h prime of 2 is going to be the value that I found up here. Remember that h prime of 2 was 2/3. Okay, and I'm going to leave it just like that because I don't want to mess anything up. Okay, it's close enough. Alright, part C is a little bit of a rabbit trail you have to kind of go on. So it says the function h of x equals x squared minus 4 over 1 minus f of x quantity cubed for x not equal to 2. It is known that the limit as x approaches 2 can be evaluated using L'Hopital's rule. Okay, using the limit as x approaches 2 of h of x, find f of 2 and f prime of 2. Show the work that leads to your answer. Okay, the first thing that I want you to think about is that since L'Hopital's rule applies, that means that the limit as x approaches 2 of the top has to equal 0, and that the limit as x approaches 2 of the bottom has to equal 0. Remember, that's the first step for you to use L'Hopital's rule, and they're telling me that I can use it. Now, obviously the top makes sense. I take my 2, I plug it in, 2 squared minus 4 is 0, check. But I know that down here I can use this information to solve for what my f of x has to be, which is one of the two things that they asked me to find. So the first thing that I'm going to do is I'm going to take my x approaching 2, I'm going to plug it in. So now I know that 1 minus f of 2 quantity cubed needs to equal 0. Well, then 1 needs to equal f of 2 cubed. So all that I did was I took that minus f of 2 cubed and I added it over to the other side. Then I'm going to cube root and cube root. My cube and my cube root are going to cross out over here, and I have that f of 2 equals the cubic root of 1, which is 1. So check, we have found one of the two things that they asked us to find. Now the other thing that they asked us to find is f prime of 2. So I want you to think about, remember, they told me that I can use L'Hopital's rule. So by L'Hopital's rule, this tells me that the limit as x approaches 2 of h of x needs to be equal to the derivatives, oops, let me put my limit here, okay, the derivative of the top and the bottom. So when I take the derivative on the top, I'm going to get x squared minus 4, the derivative is 2x, then the derivative of minus 4 is 0. Okay, then on the bottom, the derivative of 1 is 0. Derivative of this term here, you're going to have to do chain rule on. So it'll be negative 3 in the front. F of x is now squared, but then I have to multiply by the derivative of the middle, which is f prime of x. Okay? Now, I want you to think about for a second, if the limit as x approaches 2 of h of x is equal to this other limit. Okay, I want you to also think about something else that they told me way up here at the top. Look at the very top here. What did they tell me about h? They told me that h is differentiable at 2. Now, if h is differentiable at 2, that means that it also has to be continuous at 2. And so if my graph is continuous, that means that whatever my y value is, my limit down here has to also equal that same value. So they told me, what is h of 2? H of 2 is 4. Well, then this limit has to come out to be 4, because remember, I know, where can I squeeze this in? I'll put it up here. H is differentiable, so it's also continuous. So the limit as x approaches 2 of h of x needs to equal h of 2. Okay, so just think about that for a second. If I know my function is continuous, then I know my limit that I'm working on here has to also be equal to my y value, and that's the last step that I'm going to need to find my f prime, which is right here. So I'm going to take my x approaching 2, I'm going to plug it in here, here, and here. So I'm going to end up on the top with 2 times 2, which is 4 over negative 3. Down here I'm going to have an f of 2 squared, and then times an f prime of 2, that's my unknown, and then equal to 4. Well, then the first thing that I'm going to do here is kind of plug in f of 2. We already found this earlier. F of 2 is 1. So really this is 4 over negative 3. That's really just a 1 squared. Nobody cares about that. And then an f prime of 2. Then from there, I'm going to multiply this term over to the other side. So I'm going to have a negative 3 f prime of 2 to cross that off the bottom. Then I'm going to say, okay, well, I have 4 equals 4 times negative 3 is negative 12 f prime of 2. And then I'm going to divide by negative 12 on both sides to solve. So I get that f prime of 2 equals f prime of 2 equals negative 1/3. Okay? Alright, the very last part of the question. There actually is a theorem for this, but it's not in our curriculum for Part D. So I'm going to kind of reason through it with you, but I don't want you to be too hard on yourself, because there's like a whole theorem that says this, but it's not actually on the AB test usually. Okay, so it says, it is known that g of x is less than h of x for 1 to 3. So the first thing that I'm going to do is I'm going to just kind of graphically think about, I know that g is always below or equal to h on this interval. Then it says k is another function satisfying that it's always between g and h. So g is always the smallest, h is always the biggest, k is always between them. Then it says, is k continuous at 2? Justify your answer. Okay, well, I want you to think about, remember that the definition of continuous, okay, is that the limit as x approaches 2 for k of x needs to equal k of 2. That's the definition of it being continuous. So basically, I just need to show that my limit and my y value are going to come out the same. Okay, well, this is going to be the easier side for me to do. Think about it. I already know from the beginning that g of 2 and h of 2 are 4. Well, if my k value needs to be between or equal to g of 2 and h of 2, then it has to be 4. So I'm going to put k of 2 equals 4 because k of 2 is stated to be between or equal to g of 2 and h of 2. And g of 2 and h of 2 are both 4. So I already know my y value. Well, the other question then is my, my limit. Okay, so I want you to think about wherever my graphs are. If my top function, which is h of x, is approaching 4, and my bottom function, which is g of x, if it's approaching 4 as well, because they're both continuous since they're stated to be differentiable, then think about, doesn't my middle function also have to be approaching that same value? Think about it like this. Okay, here both of my graphs have to touch at 4. We'll say that h of x is kind of up here, and g of x is, we don't know, maybe down here. Okay, think about it. No matter where my k is, as I get close to this value, if it's going to be stuck between these other two guys, then there's no way that it can be approaching anything else, because it's essentially squeezed between the top function, which is my h of x, and the bottom function, which is my g of x. So if these two limits are both going to be approaching 4, and this k of x is stuck between them, then it must also be approaching 4. Okay, and so there's actually a theorem that's called the squeeze theorem that says that, but I'm just going to explain it without it. So I'm going to put the limit as x approaches 2 of k of x as I approach 2 from the left equals 4, because the limit as x approaches 2 from the left of g of x equals 4, and the limit as x approaches 2 from the left of h of x equals 4. And k of x must stay between these two functions. Okay, so think about my limit for g from the left is 4, my limit for h from the left is 4. Well, then that means that if k is staying between, his limit has to be 4 too. Now, rather than re-explaining this whole thing, I'm just going to do the same thing. I'm going to put, by the same logic, the limit as x approaches 2 from the right of k of x equals 4. Then k is continuous at x equals 2. Okay, but again, that part D was pretty tricky. I'm not really sure that I would have expected any of y'all really to get that outside of just trying to kind of explain it like I did. But anyway, good job.